Hi there. I'd really like to share with you this new test known as the GRIM test, which hopefully will become part of the standard check, one of the standard checks for new publications, and may be used to check the literature for fraud. So I did not create this test. It was created by James Heathers and Nicholas Brown, and they have a preprint of their work at PeerJ Preprints. So what is the GRIM test? Basically, what the GRIM test is relying upon is the fact that if your dataset consists of whole numbers or integers, then the average of that dataset can only take certain values. So let's work through a simple example. Imagine you have a dataset with 10 values, and these values are all zeros and ones, so they are whole numbers. You can then have these sums. These are the only possible sums you can have. You can have 10 zeros, 10 ones, or some mixture in between. And then when you take the average, you have to remember we had 10 values. So all we have to do is move the decimal place 1 to the left in this case, which results in these averages. And one thing you might notice is that we have a repeat here and here of a decimal place value. So that was one data set. What if our data set was ones and twos instead of zeros and ones? Well, in that case, we would now have these possible values. We would have the possibility of 10 ones, 10 twos, or some value in between. And again, when we take the mean, we just move one spot to the left and we get these averages. Comparing these two sets of averages, we notice that the decimal position is just repeating itself, and it's constrained to these values. So this leads us to the realization that the magnitude of the values in the dataset doesn't matter, only the size of the dataset. So if someone tells you that they have a dataset with these properties, they have 10 numbers, and these numbers are whole numbers or integers, and they tell you the average is 1.11, they are wrong. They aren't maybe wrong, they are just flat out wrong. They didn't just round incorrectly. They either made a typo somewhere in their Excel file, or lab notebook, or manuscript, or possibly they made up the number. Okay, so let's look at this graph to help illustrate the GRIM test. What I have on the x-axis is sample sizes 1 through 100, and then on the y-axis I have two decimal places. So this would be 0.00, 0.10, and it goes all the way up to 0.99. So when you have a sample size of 1, the only possible consistent value is 0.00. Green is consistent, red is inconsistent. This graph has a lot of interesting symmetry, and it also shows you that as your sample size increases, you have more consistent values. As it gets closer to 100, we get more and more consistent values. And once we get to 100, every single value is consistent. And you have a lot of interesting repetition, such as at 0.50, every even sample size is consistent, while every odd sample size is inconsistent. And then you also have something like 0.33, where every third value is consistent, and same thing with 0.66, every third value is consistent. So going back to theory, when the mean is reported to one decimal, it is possible to have inconsistent means for sample sizes 1 through 9. Once you get above that, everything will be consistent. When the mean is reported to 2 decimals, it is possible to have inconsistent means for sample sizes 1 through 99. Once you get to 100, everything is consistent, and so on. So in practice, I have implemented the GRIM test at pre-PubMed. This version here will only take 2 decimal places and will only give you inconsistent results for sample sizes 1 through 99. But I also have a general GRIM test, which will take more decimal places and larger sample sizes. So there's a more advanced use of the GRIM test. If you have a percent, such as 50.0%, you can use that like a mean by converting it to 0.500. There's also a more complicated use where if your data set is not whole numbers, you can still technically use the GRIM test. For example, here I have 10 values reported to 1 decimal place. This is the data set of 10 values. This isn't the mean, this isn't the sum, this is the actual data set. You can convert the data set to whole numbers by just multiplying every value by 10. And then if you go to use the GRIM test, make sure to multiply the mean by 10 when you use the GRIM test. Okay, I hope you found this video useful, and we'll be using the GRIM test to check averages that you find in publications.